A because it's one of perhaps several that we'll do on this particular sample. We want to put this in hydrochloric acid, one normal, and right now I'm going to look and see if there's any bubbling, which would be the carbonates coming off as carbon dioxide. I don't see anything right now, so we'll make a note of that. It's no bubbling with acid. Still don't see any bubbling. And I'm going to, let's put a magnet in there. We can stir it with the automatic magnetic stir. Okay, let that stir. I'm going to make a note of what we're doing here. So. Okay, got this well stirred, and again, I don't see anything in here that would indicate that there were carbonates. Now, if there were any, and of course there could be, and they would just have come off microscopically as bubbles during this stirring process. However, in order to complete this, we're going to let this, we're going to heat this at 80 degrees centigrade for 24 hours. Okay, C73A goes into the oven. This oven is set to maintain a heat temperature of 80 degrees centigrade, and time, we'll mark the time that we've done this. Okay, we're coming back now to revisit this sample. It's been in the oven for 24 hours, approximately. Doesn't have to be exact on these type of things. It's but 24 hours guarantees that there is no more reaction to take place with the acid. Put a note in our out of oven. Put the time down. Now let's filter this. Okay, let's set up the Buchner filter apparatus. Now we want to take our sample and treat it next with base. And what I'm going to do is take some sodium hydroxide and wash this out of the filter paper. Now, the reason for this particular process is to get and dissolve any humic acids. Humic acids are plant acids that may contaminate it. So if a plant grew there and over the past 5 or 6 years, that's a possibility that the juices, shall we say, from the plant would have covered this material, soaked into it, at least on the surface, in the fractures of it, and contaminate it with new carbon. We don't want we certainly don't want that to change our measurements and influence the accuracy of our results. So again, we're operating at 110 milliliters of this particular type of solvent, sodium hydroxide. And let's stir that again also. These things are caustic. They're somewhat diluted. This is 1/10 normal. But nevertheless, they can be irritating the skin, so we want to make sure we get we don't have any that drips around on the tables, and we get it on our skin in any way. Now we'll go back over to the mixer and mix this one up just like we did the other one. Back to our mixer, and now we don't expect any kind of bubbling here. We'll let this run for about 10 minutes. Okay, we're ready to move. This has been there long enough. Now we'll go back to the oven. Here we are 24 hours later, and let's get our lamp so it's warm. Now this looks like it's a little bit different color. It seems to be more syrupy than the other one, and it's because some of these either large organic compounds or organic molecules that form almost like a soap type of suspension. Okay, we have to set up our filter process again.
So after another washing, it's back to the oven for sample C73A.
Okay, here's our sample now ready to go in the oven. We want to dry it completely. Put it right there. Again, making notes of what we have done in the process. Time of day and the date. Okay, it's been takes about 4 to 6 hours to get it really dry, and let's see how we're doing. Oh yeah, it looks real nice now. Dried up real nicely. See, it's real powdery right now. Let's take this and now let's convert. The next thing we want to do is convert this to charcoal, and that means to drive out any organic compounds that are remaining. There could be gasoline, for example, coal, could be oils, some natural gas perhaps, and we want to get down to just the final coal. So let's put that in our crucible and heat it and burn off the other contaminating products. Now to make charcoal, if you remember from your chemistry days, we want to heat wood or coal, for example, in the absence of air, so it doesn't burn itself, but only the volatile compounds that are in it will burn off. And we want to heat this to red heat as much as possible.